So we can convert degrees Fahrenheit to degrees Celsius, and we often have to do this a fair amount since the Americans use Fahrenheit and we're using degrees Celsius. So a couple benchmarks that we can use are 100 degrees Celsius is equal to 212 degrees Fahrenheit. Okay, so the boiling point of water is 200 degrees Celsius, 212 degrees Fahrenheit. So 37 degrees Celsius represents body temperature, and that's about 98.6 degrees Fahrenheit. So we want to determine the equation to convert Fahrenheit to Celsius. So we're kind of going this way. So Celsius should represent the output or the dependent variable or the y variable. Okay, so we're going to just maybe make sure we have, so y is our dependent, and that is degrees Celsius. So the independent is going to be our degrees Fahrenheit. So our input is degrees Fahrenheit, our output should be degrees Celsius. The y-intercept is going to represent then when the degrees Fahrenheit is 0. So it's going to be the temperature when in degrees Celsius when the Fahrenheit is 0. So y-intercept will represent degrees Celsius when degrees Fahrenheit equals 0. Okay, so let's work out the rate. What is the rate of conversion from Fahrenheit to Celsius? So our change in y, okay, so our slope, our change in y over change in x is going to be the change in degrees Celsius. So we're going to end, let's maybe use 100 as our end point and 37 degrees Celsius as start point. So 212 degrees Fahrenheit is my end point and 98.6 degrees is our start point. Okay, so those are our start and end points, and that's going to give us our displacement, our change in y, and change in x. Okay, so when we work this out, okay, so 100 minus 37 is going to give us 63 degrees. So an increase of positive 63 degrees, and that same increase in degrees Fahrenheit is going to be 212 minus 98.6, and that's going to be 113.4 degrees Fahrenheit. Okay, so now we should maybe change this into a unit rate. So we're going to do 63 divided by 113.4, and that's going to give us 0.55, and I'm going to round that to 56. So it's 5 repeating. And this is degrees Celsius for 1 degree Fahrenheit. Okay, so 1 degree Celsius or 1 degree change in Fahrenheit gives us only a 0.56 degree change in Celsius. So it's about almost a 2-to-1 change. Okay, so I'm going to start writing my equation. Degrees Celsius is equal to, so y equals mx plus b. My slope is going to be 0.56. Actually, you know what? I think I'm going to use the actual fraction. Okay, so when we simplify that fraction, we're actually going to get 5 over 9. So 5 over 9 times degrees Fahrenheit plus the y-intercept is going to give us our equation that converts Fahrenheit to Celsius. Okay, so to work this out, we can plug in any pair of degrees Celsius and degrees Fahrenheit. Okay, so I'm going to use maybe 212 and 100. And then we're going to calculate the b value, the y-intercept. So when we work this out, we go 9 over 5 times 212. Okay, so 9 divided by 5 times 212 is going to give me 117.7 repeating. So 117.7 I'm going to round that to 0.78 plus b. When I solve for b, it's 100 minus 117.8, so it's going to be negative 17.78 degrees Celsius. So when we hit 0 degrees Fahrenheit, we're talking about close to negative 18 degrees Celsius. Okay, so then my equation looks like this. Degrees Celsius equals 5 over 9 times degrees Fahrenheit minus 17.78 degrees Celsius. So there is my equation. I can write it as y equals mx plus b. Okay, so it looks like that. Okay, so this one here, we've been given an electrical charge is determined by the number of kilowatt hours of use. So we're connecting these two quantities in a relationship. So electrical charge is dependent, and it's dependent on how many kilowatt hours we use. And there's also a service charge that's associated with this as well. So when I'm going to write this in a table. Okay, we could sketch a graph, but I'm going to do this one in a table. So my independent is kilowatt hours, and my charge, so 150 kilowatt hours gives us a charge of $18.75. 360 kilowatt hours gives me a charge of $29.25. Okay, now if I want to find my change in X and my change in Y, well, my change in X occurs out here. So my change in X is going to be an increase of 210 kilowatt hours. Okay, here my change in Y is going to be, it looks like $10.50. Okay, 10.50, yeah, it looks like $10.50. So I can determine my slope from my table. Okay, so my slope is equal to an increase of 10.50 over 210 kilowatt hours. Okay, so my unit rate then works out to be, when I divide that, it's going to be, looks like 5%. Okay, so 10.5 divided by 210, okay, gives me 0.05. And so that represents dollars per 1 kilowatt hour. So every kilowatt hour costs me about 5 cents. Okay, so there's my rate. I have my charge is equal to my rate times the number of kilowatt hours plus some starting value, which is our service charge. So I want to be clear that starting value is my service charge, that plus B. Okay, and then it definitely looks like that's the case in my relationship. So then if I want to find out the B, I can plug in again any pair. So I'm going to choose a charge of $18.75 that goes with a kilowatt hours of 150 kilowatt hours plus B. Okay, so 0.05 times 150 is going to give me $7.50. Okay, so we get 8.75 is equal to 7.50 plus B. Okay, so I'm going to subtract $7.50 from both sides. I end up with $11.25, and that is my starting amount, or in this case, it's my service charge. Okay, that's the amount I get charged before I get charged my rate. So my equation then works out to be cost is equal to $0.05 per kilowatt hour times the kilowatt hours plus the service charge of $11.25. Or you can write it as y equals mx plus b. Okay, so either one of those represents the equation relationship for this particular problem.